Right, so today we'll start with wrapper classes, and we have already seen the primitive types, and type is int a is equal to 9. So this is a primitive type variable a, and the value is stored 99 in this. For this, how the memory will be allocated? Somewhere the a is, so these are the memories. So this is method area, stack and heap, right? So inside the stack memory, in somewhere in some local place, this a memory will be allocated, and the memory it stores some memory like this. So this is a somewhere allocated and the name is a, the value is 99, right? And how long this a will be available? Till the memory location in which stack frame the a memory is allocated, till this frame is live, this a memory also will be available, and you can access it within that frame only. But what I want is, say my requirement like this, I will have a reference variable, this is a reference variable, and I want to create an object. This is an object, and the reference variable is pointing to this object. Say reference variable is pointing to this object, this, right? And this object should contain here 99. The object value should be 99, right? Then this can be called as a wrapper object. This will be called as an object, means an object has to contain the value. But previously we did the same thing. What we did here is, we did the same thing. What we did is, say one object we have created. Inside the object you have 99. But in that case it was completely different. Say here this is a memory location, and in this memory location I have a value here. Say it is 99, right? And some memory, some name. Say for this the name is SID. If I do like this, then this is not an object, or it is not a value of this complete object. This SID 99 is not a value of this complete object. It is SID 99 is an instance variable. It is an instance member of this complete object, right? It is not the direct value of the object. Now what I want this 99 has to be considered directly as one object. This complete object has to contain 99. I want like this. If you want to do like this, you have to create an object, and inside the object you have to write 99. Means this line you have to write now like this: int a is equal to say new int of 99. Something like this you have to do. Okay, you have to create an object, and the object value should be 99, right? Why you will do like this? Why this object? The 99 primitive is already available, a integer type, and a value is 99. You have already done, but still this is not enough. You want an object, and inside the object only the value has to be stored. Means 99 should be considered as an object. It should not be considered as a primitive type. This is what I want. Why you want like this? So the requirement is like this. I have an object type array. For example, here I am creating an object type array. Object obj is equal to, say it is an array, so new object of sum 5, right? New object of sum 5. Now if I write here object, or if I want to initialize, obj is equal to, or obj 0 is equal to new object. One object is stored into obj 0. If I store like this, object or not object, obj 1 is equal to say hello, or hello directly I will not write, new string of say hello, right? If I do like this, then how the memory will be allocated? This obj is a reference variable, right? So obj is a reference variable. You take a reference variable inside the main method stack somewhere. So this is a reference variable, and the name of this reference variable is say obj, but it is an array. Okay, it is an array. And when you will say new object of 5, it means it has to allocate a memory something like this. So this is the memory. Under that you have an array, and array is like this. This is an array, and array memory is in this way. This is 1, first element, second element, third element, fourth and fifth element, like this, right? Fourth and fifth element. And when we create the array, first time when you have said here obj of 0 is equal to new object, this new object is a memory, it is a different object. When you will say a new object, then one more object is created somewhere. Say this is the object created, somewhere an object is created. So this is the object created, and this object address has to assign to, so this address is say 1020. This object address has to assign here in the first index 1020. Means this points to this memory location, points into this. It points here, right? One object is stored into the object array. Address, one object address is stored into this array. Object address is stored. Again, same way when you will say new hello, for hello somewhere one more memory will be allocated. One more memory will be allocated. So this is, here is a memory located, and inside this memory you have hello. So this is hello. This memory address, say 1040. 1040 is stored into the next index. This is 1040, right? Then this is pointing into this, right? This is pointing to this. And the object array, object of 5, means this complete all, these all are the, these all one by one, 0, 1, 2, 3, all these are the reference variable which can contains the address of an object, right? We can contain the address of an object. Now if I write obj of say 2 is equal to 99, what is the meaning? 99 should be an object. That object address has to store into this third index. Object, it should be create an object first. So I am creating an object. This is an object, and the object content is 99. Object content should be 99, and this object address is say 1060. This 1060 address has to store into 1060, third index of the array, and this has to point into this. This has to point here, right? Like this. If I directly write obj 2 is equal to 99, this 99 will not create an object. But according to this statement and according to this diagram, this should be an object. This should be an object. Object address is has to store into this, right? But when you will write the code like this, just 99, obj 2 is equal to 99, this 99 will not be an object. Then what it will, when JVM will try to do is, JVM will try to store 99 directly in this location. 99 directly in this location, right? So this is not okay, you cannot do it. When the reference, when the obj is a reference variable, all this, index 1, index 2, 3, 4, all are the reference variable. A reference variable can never contain an object. Or if I like this, for example, assume obj, so obj 5, if I just write this, or if I say it is null, obj 5 is equal to null. What is the meaning of that? Obj is a reference variable and it is not pointing to any object, so it is null. If obj is containing any value, then what it should contain? It should contain the address of an object. So you can say here like this, obj is equal to new object. One new object is created, that object address is assigned to obj 5, it is valid. But if I write obj 5 is equal to say 10, then 10 is not an object, it is not going to create any object. 10 you are directly storing into a reference variable. A reference variable cannot contain any this kind of values. Reference variable has to directly contain the address of any other object, right? So because of this reason, this obj 2 is equal to 99, this you cannot do, it is not valid. You cannot do it like this. So what you have to do? You need an object. Here you need an object. This is one use of wrapper class. Why wrapper class is required? Wrapper class one use is when object is required in some place, you cannot use the primitive data type. Right? If the requirement is like this, say integer type variable you are storing into a primitive value, fine. Primitive type variable, primitive type value, fine. But reference type variable and I need to store a primitive type value, you cannot do it. Reference type variable, primitive type value you have to store, you cannot do it. What you have to do? You have to create an object by using this 99. That object address has to store into this obj2. Right? So this is one use of wrapper object. Means you can say wrapper objects are the objects which create some objects by using the primitive type variable, primitive type value, primitive type literal. Wrapper object are the objects which contains primitive type values. Means instead of using primitive value directly, you create an object, inside the object store the primitive value and use that as an object. Right? One use is this. Next, another use is, suppose if I have a class, say class ABC, and if I create an object of ABC, A1 is equal to new ABC. If you do like this, then whatever methods you will define inside this ABC, whatever method you will define inside this ABC, all that method can be accessed with A1 reference variable, A1.SumShow, A1.Disp, like this. On top of that, whatever other methods inherited from the object class, for example, here you have extends object. It is already there, right, by default automatically. So whatever object class methods are inherited to ABC, those methods also can be used with this A1. For example, if I say A1.hashcode, A1.hashcode, then it gives some integer value, say int x is equal to, or you say hash value is equal to. You have not designed any hashcode method inside this ABC, but still you can apply the hashcode function which is inherited from object class, and you can apply that into this object. Now assume if I have a primitive variable, int b is equal to say some 88, and can I tell b dot hash code? Can I say like this, b dot hash code? I cannot apply b dot hash code. Why? Because b is a primitive type variable and a function should be applied on an object, and b is not an object. B is a primitive type variable, somewhere it gets the memory. You cannot apply any function you cannot apply directly on b to perform any operation. If you need to perform any operation on b, you have to design those operations first. Explicitly you have to tell, okay, this is the operation, this is going to work on b. Whatever built-in already ready-made functions are there, those functions you cannot directly apply on b because b is not an object. Built-in functions or inherited functions can be applied only on the object. In primitive type, you cannot do it. So because of this reason, again, this is also, here I need to apply, say I need to apply the hashcode function here on b object. If I need to apply hashcode function on b, then for b I need to design a hashcode function explicitly. I need to write the code, implementation, everything, then only I can apply. Already ready-made built-in function of hashcode which is available in object class, I cannot apply into primitive type variable. So this is the another use of wrapper classes, or why you need the primitive variable as an object. Right? So this is the second use we have seen. First use is where the object is required, you cannot use primitive type. First use. Second use is if you need to apply any ready-made built-in functions on the primitive type, you cannot do. If you want to apply those functions, then primitive type should be considered as an object. Instead of creating primitive variable directly, you need to create those as an object. Right? So this is another use of wrapper classes, why wrapper classes are required. Next is, suppose we have seen multi-threading somewhere, or if you don't know, we are going to see later. In multi-threading, assume this is an object A1, this is an object A1, and I don't want to share this A1 object into multiple threads at a time. Means multiple threads should not be allowed to access this A1 object at a time. One by one it has to access. Now if I want to do like this, what do you have to do? You have to put the lock on. On this object the lock should be on, and then multiple threads cannot use this ABC object at a time. The same thing I want to do with B, assume. B should not be accessed by multiple threads at a time. Then what will you do? Can I put a lock on B? You cannot do it. Why? Because B is not an object. It is a primitive type variable, and variable cannot have a lock. The lock is available only on the objects. Right? Lock is available only on the object. So this is another use of why primitive should be used as a object. Why primitive should be used as an object. Next, suppose in collection framework we have seen array list. Array list. AL is equal to say new array list. One collection type object is created. Collection type object means group of objects. A group of objects. Or you can say it like this in your heap memory somewhere. Assume this is one group, and the group is say AL. Okay, this group name I'll give here as a AL, means it is array list. This is array list, and inside this array list I need to put so many objects. It's a group of students. Then this array list is a group of students, and here I'll use so many students. So this is S1 is one student, S2 another student, S3 another student, something like this. Group of students are referring with AL. This is group of students referring with AL. Now same way I need another group. It's the same way array list one, array list group I need, and in that group I need to put all the primitive int type variables. Say I have one more group, or in the same group only. Suppose here in the same group only I have A1 one primitive type, A2 primitive type, A3 primitive type, like this I want. A group of primitive type variables I want to store in an array list in the collection framework. You cannot do that because collection framework, whatever classes are designed, those classes are actually internally similar like this object type array. Similar like this object type array. So internally collection framework, all the objects or all the groups contains only the objects. This S1 is an object, S2 is an object, S3 is an object, but A1, A2, A3 are the primitive types. Primitive types you cannot store into any collection. You have to store only the objects. So in this also I need to use the primitive values as a object. So to overcome with all these problems or with all these advantages, Sun Microsystem what they did, for each primitive type data type, say you have byte, sort, int, long, float, double, and boolean, right? You have these 8 primitive data types: byte, sort, int, long, float, double, and boolean, right? One more, that is char. For each of these primitive type, they have designed one corresponding class. For byte they have given byte. For short they have given, I'll write it like this. For byte corresponding wrapper class is byte. They have designed a class. For short they have given short. For int they have given int, integer. Same way for long, for double, for character. For each primitive type one corresponding class is designed. Now wherever you need to use byte as primitive, if I need to use byte as primitive, byte, say b is equal to 10. Instead of using this primitive I can use byte b1 is equal to new byte of 10. Now this becomes an object. Now when it is an object, you can store into this object array. You can apply all the functions which is available in the object class inherited functions. You can store into this array list, means collection framework. You can provide a lock on this to avoid multi-threaded, or some other operations, whatever other operations you want, you can do. So now, for each primitive type, Sun microsystem has already designed corresponding class, and you can, that is called as repar classes. Those are called as repar classes. So same way for double, they have given classes double. Double. For long, class is long. For boolean, for char, class is designed characters. Right. So these are the primitive types and corresponding repar class. Primitive types and corresponding repar class. When you can use primitive type and why repar class is required. Repar classes are required, right? These are the primitive type corresponding repar classes is already designed. Now, if I want to design my own repar class, for example, assume for integer type, for int, Sun microsystem has not given any integer class and I need an object, right? Sun microsystem has not given any corresponding repar class for int primitive type, and I need a int, instead of primitive variable int, I need an object of type integer. Then what you have to do? You have to design your own repar class first. And how will you design it? Say, I'll take a different package. So this is com dot repar dot say p1, and I need a test. Right, say it is this, and here int x is equal to 99. Right, so just print x. It is printing x fine. X, it is okay. But what I want is, I don't want to use this x directly. I want, instead of that, I want a object. So what I will do is, say I'll define a class my integer. My integer is a class, right? Then this class automatically extends the object class, and whatever functions are there in object class, all are inherited into this. So here what I will do is, say int val is a variable, and I'll take a constructor to initialize this my integer. Say int 1 val it is taking, and this is this val is equal to that, right? Now whenever I need this int x is equal to 99, what I will do is, my integer in1 is equal to new my integer of setup, right? This. Now wherever you need a primitive type variable int x, instead of that you go with the my integer class and create the object. Now this is almost exactly same according and similar like with this primitive, but what advantage you are getting on that? All the functions, say here if I say in1 dot hash code, you can apply, but can I apply here x dot hash code? You cannot, because x is not an object and you cannot apply this hash code, right? You cannot apply the hash code, but in this in1 dot hash code you can apply, right? So this is your repar class. This is your repar class. Now you already know the toString function. So here what I will do is, I'll override the toString function also, which is inherited from the string, and it has to return like this. Return val and this, right? You guys should understand this, okay? Val. Why I am concatenating one empty string with this? Because val is a primitive type int, and this function return type is string type. So val I am converting to string, and that only I am returning. Now here, say if I print in1 and run. Okay, hash code currently I am not using, later I will use. So here what we did, one primitive type x, and the value is 99, printing x. One repar type object of my type, my integer, and printing. Now you see that this works exactly similar like primitive. right? This is 99 and 10. Do one more integer type, suppose primitive. I will not use primitive type, I will use my integer. Say in2 is equal to new my integer of say 80 and print in2. Run it. It is fine, 88. So this is your wrapper class. Now wherever you need primitive type int, you use my integer. Same way, if I need a byte object I need, then what do? Take one more class, say class my byte, and declare some variables in this. And wherever you need byte type, data type, byte primitive type, you use byte class. Same way, the Sun microsystem, for each 8 primitive type on corresponding class they have designed, and that classes are called as wrapper classes. And why these are called as wrapper classes? Because these classes are wrapping the primitive type value. These classes are wrapping the primitive type value and creating an object for this. When these classes are wrapping primitive type value into an object, because of that they are called as wrapper classes. Apart from this, so when you are not using primitive, instead of that you are using the wrapper, whatever functions are available in the object class, all is inherited and all you can apply into this. On top of that, they have already overridden some function. For example, so hashcode function is there. In the object class and it is inherited. In wrapper class, say assume I am overriding this hashcode function, and hashcode function should return a value, so I am saying it is val. This hashcode function is overridden, and the hash value I am considering here the val itself. Now if I get the hash value of these two, say in2 dot hashcode, what will be the hashcode for this? The hashcode is the val itself. Val means it is this dot val. What is this dot val? This dot val is 88. So the hash value will be 88. So this is 88. Right? Next, same way, for the hash value for this my integer, what will be the hash value? The content itself is the hash value. How you are writing this hash code, you are overriding to get the hash value, and here you are telling that the content of the object itself is the hash value. Same way, the Sun microsystem designed all these classes in the same way, and they have said whenever you will try to get any hash value for this wrapper object, the content of the object itself is the hash value. Okay, content of the object is the hash value. So like this they have designed these wrapper classes. How you are designing here? The same way they have designed. ToString method is overridden. Here we have overridden the ToString method. What we are telling? That the content itself should be the output of the ToString function. The content is in a string form. So the ToString function is overridden and you are getting the output is the content. Same way in all these wrapper classes also, the content itself is the value of ToString function. So if you create an object of sort and if you print the reference variable, it will print the content of the object. If you create an object of integer, print the reference variable, it prints the content of the object, right? So this is how the wrapper classes are designed in JDK. You no need to design this. These are already designed in JDK and you can just use it. How it is designed? For example, integer is a class, say in5 is equal to new integer of, say it is 100, right? If I print in5, then the integer class Sun microsystem has designed similar like my integer class, and the ToString function is already overridden. The content should be the output of ToString function, right? So here the output should be 100. Hash value of this, say in5 dot hash code, check it. The value is same, the ToString function, and hashcode function is already overridden in integer class, and the content itself is the value of toString and the hashcode, right? But the problem is, so like this for all the primitive type 1 corresponding wrapper class is designed, and you can use it wherever the object is required, right? Wherever object is required. On top of this, they have given some important functions inside each wrapper classes. For example, assume I have a string variable, string str is equal to say 1, 2, 3. This is string value, and I need to convert that to primitive type, say int x is equal to or int ab is equal to str. Can I write this? Not okay. It is incompatible type. Why incompatible type? String type and integer type is a completely different types. No inheritance relationship, nothing. So a string value cannot be directly assigned into this AB. So for that, what you have to do? This string value, that is 1, 2, 3, which is string, you need to convert to integer type, and you have to store into this. How will you convert? For the conversion, you need to do some, say the per class is already not designed, not available. Then what will you do? You write some logic to convert this primitive type, this string to primitive type, and store. You have to write some logic explicitly, but it is not required. Why? Because the conversion from string to primitive int is already designed in integer class. Okay, so same way, if I design here my integer, in this my integer I have not given any method, here to convert a value from string to int, primitive type, not available. But whatever function Sun microsystem designed inside in those wrapper classes, the conversion from one type to another type is also available as a function. You just call this function, and this value, this string value, will be converted into corresponding primitive type. For example, here the function is integer dot parse int of say str. This is the function design, parse int. Where is this function available? This function is available inside the integer class as a static function, and this function is already implemented. It has the code to convert this str and store into primitive type AB. So whatever other advantages you have seen, toString function is overridden, hash code is overridden, and instead of using primitive you can use wrapper. On top of that, they have given some other important function from converting from one type to another type in all the wrapper classes. In all the wrapper classes, Sun microsystem has defined some functions to convert one type of value to another type of values. These functions are already ready. You just use that function and value gets converted. You no need to write any other code for this, right? Same way, suppose I have a string value, string str1 is equal to say the value is 1010, something like this, and assume this is a binary value. Okay, the value is in binary format. I need to convert into primitive type int ij, suppose. It should be in binary format at that case. So here I am taking it is say 1010. This is the value in binary format. And when I will store into this ij, the value binary format, if you convert this to decimal format, then it will be 10. I want to convert this str, I want to store into I and j, but the output should be 10, means it should be in decimal format. It should be in decimal format. So for this also, in corresponding integer class, function is already designed, and what you can do is you can write this one. You no need to write directly. You can put here str1 of 2. 2 specifies here the base. The base of this str1 is 2. 2 means it is in binary format, and after converting it will be here in decimal format. Now if I print here I and j, this will print here, the output is 10. 10 is in decimal format. Run it. It is 10. Means the per classes are having these functions, converting from one type to another type, string to primitive, string to int, string to byte, byte to string. This type, conversion of one type to another type function is already designed in wrapper classes. Next, conversion from one base to another base, binary to decimal, decimal to binary, octal to binary, binary to octal. So this conversion also from one base to another base, these functions are also designed in all the wrapper classes. So you no need to do explicitly anything on that. All these functions are already designed in wrapper classes, in each wrapper classes. So what are the advantages we have discussed so far of wrapper classes? The first advantage is in the diagram over here you can see. Say we need an object. We don't want to use primitive type. We need an object because I need to store into an object array. Then by using primitive type, instead of creating primitive, by using wrapper type, you can create the object and you can store into array. First advantage. Second advantage is if the instead of primitive, if you use as an object, then whatever ready-made functions are available in object class, all those functions can be applied into the wrapper objects. Next is the collection framework cannot contain the primitive type values, collection framework here in array list, and I need to store those values into collection. Then don't store that as primitive, store that as a wrapper object. Next, conversion from, according to this diagram, conversion from one type to another type, conversion from one base to another base, these also functions are already designed in wrapper classes. On top of this, all the inherited function of object class is already overridden. For example, toString function is overridden and the content itself is the value of the toString. Hashcode is overridden, the content itself is the function of hashcode. Equals method also overridden in all the wrapper classes. In all the wrapper classes, equals method also overridden, and equals method compares the content. And if you don't know what is equals method, that's first in object class you have to see the equals method, then this point you will understand here. I hope you guys already know what is equals method. And the equals method is also overridden in all the wrapper classes, and equals method compares the content of all the wrapper object. Next, on top of this, almost all the mathematical function, like the mathematical functions say I have a primitive value, say int some m is equal to something, or int say double d is equal to somewhere, something like this. I want to get the absolute of this, absolute of double. Here you cannot do it, you have to do explicitly. But if you take the double class wrapper object for this, absolute function is already designed, you just call it and you will get the absolute value. Same way, floor value, sill value, or what, almost all the functions, whatever operation you can perform on an object, all the or on a primitive value or some number, whatever operations you can perform, so something like this 12. I want to find out the square root of this. If I take that as a primitive type, say int ab is equal to 12, square root is required, then you write some logic for this. But if you take that as wrapper type, already function is designed, square root, you just call it and you will get the square root of 2. So like this, almost all the mathematical functions are already designed in all the wrapper classes, and if you take that as a wrapper class, all those functions you can apply directly, you no need to write. And some other requirement also we have seen in case of multi-threading. If I want to lock an object, I don't want to allow multiple threads to access the same object at a time, then I can provide a lock. But if it is primitive type, it is not an object, you cannot provide a lock. So you need to consider that as a wrapper object. So this is the use of wrapper classes and why wrapper classes are required in Java, right? So and the wrapper object is, when you create an object by using wrapper class, then this is called as wrapper object, right? This is a wrapper object of type integer because you have created that by using wrapper class, right? One more important point is, you remember the call by value and call by reference, call by value and call by reference. For example, you have a class here, it's a class ABC. In class ABC, I have a function void show. is having a integer type argument int a. Suppose it is int a. Now if I want to call the show function from the main method, suppose here abc, say I'll directly select this new abc of new abc dot show, and I need to provide here a primitive value, and the value here first I'll design as say int some k is equal to 99, and here I'm giving k, right? Here I'm giving k. Now when you will call this function abc function, you are calling with the abc object you are calling the show function. Show function is taking k as an argument, and now 99 is stored into this a. Here if I modify a is equal to say 88, will it change the value of this k? It will not change, right? Because it is primitive type. But instead of this k, say here I have one more function, void disp, and this is taking an argument of type wrapper, say my integer im. This is my integer, right? And I need to call this. So what I'll do is first I am creating an object of my integer in, say some 6 is equal to now my integer of say 22, right? Now when I will call new abc dot show of in 6 not show, it is disp actually, so it is disp, right? So here in6 I am supplying, and inside this function now what I will do is in dot value is equal to say 33. Now will it change here in6 value 22233 or not? It will change, right? Definitely it will change. Say after doing this, say I'll print here k I'll print, and I'll print this in6 also, okay, and see what are the values available. Printing k and printing in6, run it. K remains same 99, but what about in6? in6 value is changed to 33. This is one disadvantage you can say. You are using primitive type, and if the called function change the value of primitive type, it is not going to affect into the main function. But instead of primitive, if I use a wrapper object and if I pass that as an argument in this, and if the called function change that value, it is actually affecting with the actual value. Now what will you do to overcome with this? I don't want like this. The value should not be changed. Why the value should not be changed? Assume it is not in6, it is a salary, somebody's salary, and salary is say this, okay, and this is I am giving here salary. And when I will come into this salary, and salary is modified to something like this, say 4000. Previously your salary is this. Now when you will call this function, which one, disp, in disp the salary gets modified, and now your current CTC is this. Now you run, your CTC is changed. This CTC is changed. Can you accept this? It is not okay, right? But if I take the salary as primitive, it will change. So this is called call by value and call by reference. In case of call by reference, the caller, if the called function change the value, it actually affects with the actual value. It actually affects the actual value, right? So it should not do. It should not happen. So what you have to do, we have seen in the last class. One concept you can apply is don't pass the salary here directly. Instead of that, clone the salary object and give that cloned object, don't give the actual object. You can apply cloning here. Or what you can do is the wrapper object should be immutable. Wrapper object should be immutable. Now what is the immutability means? Immutability means after creating an object, the content of the object is modifiable or not. If the content of an object is modifiable, if anybody can modify that content of the object, then the object is called as mutable. Mutable object. Mutable object means the object content can be modified. Immutable object means the object content cannot be modified once it is created. Whatever value you have given at the time of creating the object, the value cannot be modified. So all the wrapper class are designed as immutable. Wrapper classes must be immutable. Means once I create the object of my integer, the value of my integer object should not be modified. It should not change. If anybody tries also, it should not allow to do that. So what will you do for that? You have to declare that as final. Done. If it is final now, see here it is giving error. Whenever any function is trying to call this value, it is impossible. You cannot do it because the object is immutable. Object is immutable, and immutable object cannot be modified. In the same way, all the wrapper classes, all 8 wrapper classes are designed as immutable in Java. You cannot modify. So you no need to worry about this call by value and call by reference when you are using wrapper object instead of primitive data type, because the object is immutable. Next, one more important concept is assume maybe you already know string str1 is equal to say hello, and say I have one more str, okay, I'll take it 4 and this is as 3, so this is hi, this. Now if I write here, say int x is equal to str3 compare to str4, right? Compare to str4. What will be the value of x? And what this compare to function does in string class? So it is xy, and I am printing here xy. Run it and check what is the value of xy. Xy value is -4. What compare to function does in string class, how it works, and why this compare to function is required. In string class, you have already seen the compare to function is to compare two string object. How it is comparing? str3 is the current object, because on that you are calling compare to, and str4 you are giving as an argument. Now what compare to function will do? Current object will compare with the argument. What is the current object? Current object is str3. Means str3 will compare with str4, and whatever difference is there between str3 and str4, that will be the result. Integer different. Why this difference is required? For sorting purpose. Assume I have multiple string objects. String str5 is equal to say Java, str say some JSP, something like this. I have multiple string objects, and all these string objects I need to sort. How will you sort? For example, I have a group of elements, say 11, then I have some 22, I have 1, I have some 45, 1, 2, 85, something like this. These are the elements, say it is a group and it is an array somewhere, and I need to sort. The element should be sorted in ascending order, in descending order, some order I need to sort. Then what you have to do? Any sorting algorithm you apply, say bubble sort, any one sort you are applying, what you have to do? First element compare with the second element, check the difference, which one is greater. If the result is positive, then you keep it as it is. If the result is negative, swap the number or something like this. This kind of algorithm you have to apply here, and the element can be sorted. Now assume this is string objects. Same way I want to sort this string objects. Then what you have to do? A string object has to be compared. This string should be compared with this string. This string has to compare with this string, and get the different, and based on the different you have to sort. So in a string object different, to get the compare the object and get the different, you no need to do. That is doing by compare to function, which is already designed in a string class, and you can just use it, gives the different, and based on that you sort. That is your wish. Same way, now from where the compare to function is coming in the string class? It is coming from comparable interface. So string class is designed like this. Class string implements comparable interface. this is string class is designed like this. String class implements comparable interface, and inside the comparable interface this compare to function is already available at function, and a string class is overriding that function, and the implementation is given for comparing the string object inside the string class. Same way, all the wrapper classes, whatever wrapper classes are designed in JDK, all these wrapper classes implements comparable. For example, here I want to comparable implements comparable, implementing the interface. If I want to implement the comparable interface, I had to override here compare to function is also overridden. Now assume here I'll write here my integers. And I can use here one generics. The concept you will understand generics later. Currently I am just writing it in this way. My integers. Okay, fine. So it has to return like this. Return this dot val minus or dot val, something like this. This is compared to. Now assume I have two my integer object and I need to compare and to get the difference. Then what will you do? In the main function, my integer, say my_in is equal to 1 is equal to new my integer of say 99, and again same. So this is my integer 2, and this value is say sum 88, right? Now I need to compare these two. I don't need any logic for this. What I can do is int x is equal to, or int sum d is equal to my in1 dot compare to my in2. That's it. Print the d and check d. Where is the error? Okay, this line I have to run it. It is 11. Difference is 11. D is 11. 99 and 88. Difference is 11. Now assume you have, this is one object, another object, some 100 objects are there of my integer type, and I need to sort. For sorting of my integer type object, you no need to write any other logic. Why? Because the compare to is already implemented in this, and you just call the compare to get the difference, and based on the result of the compare to function, that is d, based on this you sort in ascending or descending, whatever you want, right? So the same way how you have implemented here compare to method, how you have comparable interface implemented, compare to function you have overridden. In the same way, in all the wrapper objects, in all the wrapper classes, they have already implemented the comparable interface. They have overridden the compare to function. For example, say integer. Now I'll take this integer which is wrapper class. Integer in8 is equal to some new integer of say 120. Integer in9 is equal to new integer of some 123, something like this. Now I want to apply the compare to method on this. Int e is equal to in8 dot compare to in9, and print the e and check. E check. The result is -1. Actually should not be -1. The result they have given here, if it is greater, give -1. If it is smaller, give 1. If it is equal, then give 0. For example, here if I give say 0, then the result is same. Then compared to they have given here 0 only. The result is 0. If this is say 120 129, something like this. Now say the result is negative. Negative means you no need to swap, keep as it is in case of sorting, right? Or if it is positive, you need to swap. If it is 0, keep as it is, no problem, compare the next one. Something, this kind of algorithms you have to apply for sorting purpose. And for sorting you need to compare. Comparison logic you no need to write. The compare to function is already implemented. in all the wrapper classes. So this is one more important point you have to remember, that all the wrapper objects is by default comparable type. You don't need to write anything on that for comparison logic. Next, one more important point you have to remember is all the comparable object is all the wrapper objects are also serializable. What is the meaning of serializable? That you will see later. What is actually serializable is, we'll see in IO package. You just currently remember that all the wrapper objects are also serializable. So these two very important point for interview purpose. You can remember that all the wrapper objects are comparable, all the wrapper objects are serializable, and all the wrapper objects are immutable also, immutability. These points you have to remember very clearly. Okay, immutability, comparable, and serializable. So what are the main important purposes of wrapper object we have seen? Primitive. If the variable is primitive type, you cannot store it into object type, or you cannot consider as an object. Next, if the primitive type, you cannot apply the object class functions, but in case of wrapper you can apply the object class functions. Next, in case of wrapper, you cannot store in case of primitive you cannot store into the collection framework, but in case of wrapper you can store into the collection framework. Next, what are the next functions? Conversion from one type to another type, one base to another base, built-in ready-made function for almost all the operations. Next, almost all the wrapper classes are already overriding the inherited function of object class, like toString, hashcode, equals. All these are already overridden. Next, all the wrapper objects are immutable, so you no need to worry about for call by value and call by reference. Next, wrapper objects are serializable and wrapper objects are comparable. So these points are very important for all the wrapper objects. So these are the wrapper classes. What is the use of wrapper class, where wrapper class is required, how you will use wrapper class, all these things.